Good afternoon and welcome. Thank you for all joining us again. This is my name is Mark Richardson. I'm with Vibrant Technology and joined again by my friend and colleague Dan Ambre from Full Spectrum Diagnostics. And we welcome you to another MEscope video ODS webinar. You may recognize that we have flip-flopped the name. We used to be called ODS videos. In the past month, we have rebranded, if you will, or renamed to video ODS. It's a little more in line with what our other products with our other packages with MEscope. We've got visual ODS and visual SDM and so forth. But so we changed the name a little bit. Hopefully it doesn't throw too many people off. Same product though. But we are going to go with video ODS now. So today's webinar is we're going to look at the MEscope NXT, which is a new user interface. It's been out for a few months actually, but we really haven't highlighted it too much. So we thought it'd be a good opportunity to kind of do a front to back look at the NXT user interface. It does come with, when you order an ODS, a video ODS package, it does come included with that. So you still have your traditional VES. If you're an existing MEscope user, you're more familiar with our VES user interface. But now we also have this NXT platform, which is a much more streamlined, more modern looking, and a lot easier to use interface. And we think it's going to be a big hit for us, and we hope that you get a chance to use it. And so this will be an opportunity to take a look at the wizard. We're going to walk right through everything. Dan's got a project that he's worked on, so we will get into that in just a minute. Just a few things before we get going. I did want to remind you about the Vibrant store. If you are interested in a subscription to any of our packages, you can go out to our website and click on the store and take a look at all of our packages that we have available that we have on a subscription basis. So you can do a 1-month subscription if you just want to kind of get something going. If you want to kick the tires for a little bit before committing to a full license, you can always do just a monthly subscription and then use that for however long you'd like. So that's out on our Vibrant store. In addition, we have a modal training course coming up here in a couple weeks. So if you need some additional training on modal, we're doing an introduction to modal training course. It's going to be an online course, and you can also find that out on the Vibrant store. A couple of housekeeping items before we get going here. We are going to be recording this webinar, so if you missed something along the way, we'll get a recording uploaded to our YouTube page, probably the early part of next week. I'll get that uploaded, and you can go back and walk through the webinar on your own time on the YouTube site, which is just at YouTube/Vibrant Technology. And last but not least, if you have some questions, we will go ahead and open up questions at the end of the webinar. So you can type those questions into the box there on the right-hand side of your GoToWebinar screen, and we'll get those questions answered for you. With that, let me hand things over to Dan, and we'll get going.
Good afternoon, everybody. Thanks for showing up. We haven't had a little webinar in a while, and hopefully you'll learn quite a bit out of this one. This is more practical than I've ever done before. And we're going to walk through the NXT toolbox, and like Mark was saying, I'm a big fan. The first time I used it, it wasn't ready. It was in, you know, that sort of murky zone where some things worked and some things didn't. And I put it off for a little bit, and now I use it, and I won't go back because it is, like Mark said, it's very user-friendly, and it's just an interesting application. Every time I do a job, I pull out my phone, which is, by the way, my camera for this application, and I get new data that I've never seen before. So I used to say that about all the accelerometer testing and operating deflection shape and modal that I've done. I learn something every month I've never seen before, and I've been doing this for like 30 years. Now I see a video application that I've never seen before, and it keeps it fun and keeps you on your toes. We are going to look at, uploading a video, selecting background to remove, any jitter in the phone or the application that we're using. We're going to look not only at the animation that you're going to get, we look also at the data. So there's a couple different things we want to process. One is we just take our data normally, the discrete Fourier transform, and it includes phase in that that piece of information that we're getting in the video clip. But we also want to look at the ODS-FRF, and the ODS is operating deflection shape. The FRF part of that shows us the phase. It calculates phase across the spectrum. So it allows us to do some really nice things with averaging and overlap processing, so that we reduce the noise in the data instead of having a hashy response where we're trying to find a peak. It drops the noise floor quite a bit and allows us to do a better job. And actually the data looks so much better. I'm kind of a data guy. I love the animation, but if your data doesn't look good, it appears that you're holding something back. In this case, there's plenty of tools in there that really help you understand the data really well. And there should be a few questions, I imagine, at the end. Somebody always asks about this. There is a filter that we're using. It's called an orders filter, and it's for the aliasing problem that you'll get with video clips, which is unavoidable. But it was a great piece of software allowing us to see what we couldn't see before. And it's hard to explain without a chart, so I'll wait until we get to there and figure out what's going on. Before we start, I just mentioned my phone is my high-speed camera. It's nothing super fancy. It's an iPhone 13, and I think they called it a mini because I like the size. I like to be able to put it in my pocket.
Hey Dan, sorry to interrupt. Are you presenting something? We're just seeing the title screen right
now. Not yet.
Not yet. Okay.
Yeah, I'm just monologuing here.
Okay.
So my high-speed camera is my phone, and high speed is relative, but 240 frames per second, you get an Fmax of 120 frames per second or hertz, and it's for most applications that we're looking for phase. That's plenty, and we should be able to use it and enhance what we normally take as data. So now we have a visual vantage point that is really good. Okay, well, why don't we get started? I got to jump out of here. Uh-oh. Oh, there we go. Phew. Okay.
Yeah, we can see that. There you go.
I already brought this in. I'm gonna bring it in again. This is a fan that I worked on a little while back, and I kind of resurrected it. 61 something. There we go. There are several clips of this. I'm only going to show you one, but it's one I haven't used before. There's a head-on view. There's close-ups. There's a close-up of the frame. This one's from the side, so it's a different view than I've ever taken before, and it'll give me a little information. When you're doing video ODS, you need to have multiple directions of video taken. It's a two-dimensional software, so you're gonna see X and Y. The straight-on response you're not gonna see, so you're gonna have to have at least two directions to be able to see all the motion that you wanna see. I'm gonna drop this in. You can see off to the side, there's some duct in front of me here that's blocking a little portion of the frame. Couldn't avoid that. This is belt-driven motor fan system. The motor is 1780 RPM. The fan is 1670, I think, RPM. So there's a couple closely spaced peaks there. And it's an interesting piece of a interesting machine. One other thing, we're going to have, I'll talk about it in a minute, but a reference, a known reference length. I have a ladder right here, and it has 6 rungs on it. So it's telling me this is, I believe they're 12 inches apart, so I should have a very good reference in the video frame. If you don't have something like this, maybe get a yardstick and lay it so it's in the range in the video frame, and you'll be able to scale your responses really well. Okay, just thought I'd throw that in. We have the adjust and crop wizard. So there's a whole series of wizards, aspects of this wizard, and it's inside the software portion where we're just framing everything up and getting grid points and adjusting things before we start processing the data. Once we finish processing the data, we're going to have a whole different wizard that comes up, and that's the toolbox that's really interesting and provides a lot of information for you. So we have brightness and contrast. If we bring the video in from a phone or what have you, we're going to have to turn it 90 degrees if we took it that way. This one's brought in because I already took it sideways, so it's already set up in pretty good frame. You can crop it if you want. I would come in here usually and I'd crop something like that. I'd probably get a little better view, but we're not going to do that for this one. We're going to bring the whole thing in. I hit my next. I come in here and I have to give it my frame rate that I took the data with. My high-speed camera that I bought was, I don't know, $7,000, and I rarely use it. I bring it along with me. It stays in the box. If I need it, it's there, but I haven't needed it for about 99% of my applications. I can pull out my iPhone and put it on a tripod, and I'm ready to go, which is fantastic. You don't have to bring all the electrical cables and batteries and light panels and all that. It's pretty much done for you. So I'll say that a few times, I imagine here. So my data was taken at 240 frames per second. It's in your phone. They call it slow-mo, and you need an HD 1080p slow-mo setting, and at 240 frames per second. So that's how you walk through it into the setup and camera, and you'll be able to find all the little pieces of that to get the right frame setting. This is set at 240. That elapsed time is 16.629 seconds. I need somewhere on the order of 15 to 20 seconds. That allows me a lot of leeway on, short clips are really hard to process, especially if you're moving the camera around a whole lot. You take a longer clip, you have your subject, your phone on a tripod, you have one of those Bluetooth start-stop options, and you don't have to touch the tripod. And you're like, well, why should that matter? Because if you touch it, you're flexing that tripod and it wiggles. It's like a little natural frequency going off in there, and it will shake your whole pane. So now it looks like the entire structure is shaking, and I'll show you what that looks like in a moment. I'm gonna put this about, I don't know, 11 seconds or so. And there it is. Okay, so down here, oops. What am I doing? There. Okay, so down here under elapsed time, it's 0 to 11 seconds, and it doesn't start at 0. I try to, in my clips, get a little bit away from the start and stop, just in case there's anything funky going on. I'm capturing the best part of the data that there is. Okay, when I hit next here, it pulls up a number of grid points, and this defaults to some value in the software, but you can go in here and you can make it very dense or not. In this case, I'll just leave it at 3600. I'm going to extract all the time waveforms. So there's 3600 grid points on this page, little red dots. When I extract time waveforms, it's going to find 3600X and 3600Y time waveforms. And then it's going to process all that data, and you're going to get just a pile of it. In this case, you're going to get there's 3600, you're going to get 7200. Maybe I'm doing that wrong. I should be right. But you're getting a dump truck full of sensors. Every dot on the page is a sensor, and it knows where it should be. So very cool type of application here. So I'm going to extract the time waveforms, and it's counting down, and it's going to be about five minutes. Now, the reason it's 5 minutes is because I grabbed 11 seconds worth of data. If I would have grabbed 1 second worth, it would look real choppy and it would not real clean. I enjoy the clean look to it because I think part of the analysis is looking at the data. And if the data looks trashy, the animation gets a little jumpy and it's not real clean. So anyway, I have one other thing I want to show you while we're waiting for this to happen. Oops, it's the wrong one. Got a little PowerPoint presentation here. For those of you who haven't seen this, this is the vibration fault periodic table. It's a sorting mechanism for a whole series of vibration faults. These on what I have here in the colored little squares are 35 of the most dominant vibration problems in rotating machinery. Okay, and they're in categories. So I have a sorting mechanism. I look for what's the frequency grouping, and in here we have 5 frequency groupings. We have synchronous, which is turning speed of the shaft. We have harmonics, which are multiples of turning speed, exact multiples. We have subsynchronous grouping, and it's all the peaks that will appear below the synchronous frequency or below turning speed. We have non-synchronous, which are not harmonic, so they're kind of anti-harmonic. They're fractions of turning speed. And the last part is modulation, and the modulation creates a pulsing effect that it goes through, and usually it's a combination of multiple faults. So the first thing we want to do is sort for what type of application we're looking for. Typically, this is a synchronous or harmonic type ODS process here. We're going to look at the synchronous. There's about 11 different synchronous problems, and there's a couple more looseness problems that are harmonic and a natural frequency problem. So we have probably 15 different problems on this table that can be addressed by ODS videos. So the first sorting mechanism is what frequency grouping do we have? The second sorting mechanism is what direction is dominant. So if we look at our first column here, we have a synchronous problem. We're going to look at how it behaves. Is it mostly a radial response or mostly an axial response? In this application, the red color means that it's radial, the yellow color means that it's in the axial direction of the machine, and the orange color says it can be either one. Okay, so most of the time we can pick out a couple of lots of different faults. If it's a synchronous problem here, we've gone from 35 faults down to about 12. If it's radial, we've dropped another 6 different icons off the page, and it goes down to 4. And if it's radial, then there you go. We have something else that we need to do. We have to do a diagnostic somehow. The upper right-hand corner of the block will tell you what you need to do. And in this case, it's a phase analysis. So one of those could be ODS video and see what's going on, get a good idea of what the motion is. And then you might want to come in with more 3-dimensional accelerometer-based analysis methods. But in this case, we get a good shot at it. It takes you about as long as I just talked. Take a spectrum. What's the dominant peak in the spectrum? It's at turning speed of the shaft. We go from 35 down to 11. Now, what direction is it? Well, it's in the radial direction. Well, then we pull 6 more of these icons off the table because if it's radial, it's not axial. We're down to 4. And then we do whatever phase diagnostic or time waveform or orbit, transient or ultrasonic diagnostic to walk down some more problems. So we effectively 3-step problem. We'll get into what's left, and those are probably the problems that we're looking for. I'm gonna see if it's done. I believe it should be, because I'm yammering on. Almost 8 seconds left. So we talk around that for a couple seconds. The first thing I'm gonna do here is I'm going to remove the background noise. And what is the background noise? It's camera jitter. It's if you're holding the camera while you're trying to get a clip, it'll drift all over the place. And we're going to get rid of that motion. And I'll tell you how that works in a second. First, we have to set some known distance. And I'm going to choose the rungs. So they should be what I'm looking for. So 1, 2, 3, 4, 5, and they're 12 inches apart. So that's 60 inches. And that's a pretty good known distance. If you have something very long that goes all the way across the frame of the video, even better. Okay, so in this case, I got a really nice amplitude reference, so it'll work really well later on with the data. So I'm going to hit the next button. We come up with the magnitude histogram. And I don't use this very much anymore. I see if there's something funky about it that I'll go in and try to play with it and make it a little better. But this side is for a low quantity of really high peaks, and we don't have a whole lot of those. You can see some holes in the dot structure here. This side is a lesser number of small peaks, if that makes sense. And you can see what it does to the dots on the screen. So it's kind of arbitrary. I'm going to move this back to where it was, and I'm going to proceed without messing with that, because my first thing I'm going to do over here on the other side is remove the background with the new toolbox. Okay, the old toolbox had another setup for point graphics. So putting in labels or orbits or vectors or mag and phase. And instead, for this version of the NXT program, we put it back into the wizard when we're out of the little adjustment phase of the graphics here. So we're going to finish, which is just the beginning, of course. We're going to step into the next wizard. There we go. We got a time waveform at the top, which you should know is a combination of all the frequencies going on. There's a couple rotating frequencies. There's synchronous and non-synchronous. There's subsynchronous. They're all over the place. So there's lots of different peaks in the spectrum. If you look down below, I'm gonna light this one up. This is the turning speed of the motor shaft. Okay, 1800 RPM, it's 1790 because you get a little slip. There's also a peak right here, and I wouldn't know this unless I played with it already, but this is twice running speed. So I had to call somebody on site to make sure of what the speeds of the shafts were, what the diameters of the shivs were, so we could calculate belt frequency, and we knew what was going on. There's still a lot of activity. There's a lot of different peaks in here. And some of them are aliasing peaks. And if you don't sample fast enough, you can't get enough distance away from the high frequency peaks, and they tend to roll back into the low frequency end of the spectrum. They fold over. I will show you an example of that graphically, which makes a lot more sense in a few minutes. I just want to go through the wizard first. Okay, so we got a lot going on. We got the time waveforms. We got a spectrum for X and Y for each one of those responses. And if you walk through this, you can see the peaks showing up, and the rest of it showing up on the animation. How do I want to do this? Let's see. Here's our wizard. Nothing too exciting. Couple lines showing up. I can get into the wizard and I can do any of these tasks. There's some of them I use all the time and some I've never used, but they're specialty type things. One of the nice things is I can switch the result set. So I've just come to a result where I'm animating. So I have an original set, so I can go back and start from here again if I need to. And a lot of times you might do something and have 3 or 4 result sets and you don't want to keep going because you didn't do something right in the original. You can go back to the original and set it up again. Okay, and a little wordy, but you'll see what I mean when we do this. So I can always switch the set, go back, and it's a quick changeover. There's edit point graphics, and the point graphics are mag and phase labels, point labels, their vectors, and their orbits. And this is something that just went live this week. We set it all up in a different way, and now the point graphics are a little easier to understand. I just haven't had a whole lot of practice with them yet. Number one thing here is remove background motion. So you can see the whole frame moving. Everything in the frame is moving because the camera is moving. So sitting on the tripod, the wind was blowing up there, and it would excite this response in the tripod, shook the camera, the whole frame is moving around. We're going to do a remove background motion, which we highlight all the background we want to get rid of. It will calculate the average motion of the background and then subtract that from the background and the foreground. So you're left with the real motion plus the wiggle in the camera. We'll get rid of the wiggle part and you'll get your real response back. Scientific terms here. So I'm going to remove the background motion. I can delete numbers of selected points. And I haven't played with this too much. There's delete measurements of selected points, and there's average measurements of selected points. I can go in here and make a whole bunch of things go to 0 if I want to in the background, but it's a lot easier the way they put remove background motion. It kind of is a combination of both of these subsets. We're going to do an ODS-FRF, so I'm going to be able to show you what the processing is, and it's you have a shorter data block, you have a percentage overlap of data, and in this case we're going to have like 25 averages. So what that's going to do for us is clean up this noise floor, and it looks pretty good here, but there's other plots, you know, that are jumpy. It's auto scaling all the time, but we'll get stuff like this, which is not a very good peak, and we'll want to clean it up. And the ODS-FRF does that for us, and it's a really nice application. We have a time waveform at the cursor. So right now I'm at 1790. It will calculate a little window around 1790 and create an inverse FFT, and we're going to have a time waveform at just that frequency and everything else removed. So it's kind of nice backward filtering so we can see a really good time waveform. Orders filter. The orders filter is I can't say anti-aliasing tool, it's an aliasing understanding tool where peaks in the spectrum, we don't know where they came from. And this is a really good example because there was a lot of aliased peaks, and we're going to be able to pick them out and see where they're coming from. And last, we'll record the video. We can record the whole screen. We can move things around, so we just do the image. We can have spectrum with it or waveforms, however you want. So that's a pretty easy feature, but you got to do a little setup. And then we can reprocess the raw data. So if we mess up, which, you know, this is not the easiest stuff in the world. If you mess up, you start over again. Okay, and you can just reprocess the raw video. And I spend my life doing things over that I've screwed up. So I really get good at things by testing how much I can guess. Well, let's try it. Let's remove the background motion. we're going to go in here and do an interactive point selection. We're going to select, oh, I didn't want that. We're going to do a multiple select and multiple select on polygons. And hopefully I did that right. I'm going to go in here and I'm going to draw around all the objects that are in my structure window that I'm very interested in and separate it from the stuff I'm not very interested in. And you can overlap these little things, but once you get to the end, get close enough to that point, it turns green. So it tells you, yep, you got it. So there I have red dots all the way around this area. And I'm going to do a bit more, but I just wanted to stop and show you that. I should be able to go right into the next block, which it's doing great. And this might take you 5 minutes. It might, for the first time, you might mess it up on the last little spot and have to start over, but I apologize for that, but that's all part of the learning. Up here, this frame, I don't want to block it all out because I think it's moving. And so I'm going to try to work around it. And in fact, I found one point was driving the whole analysis. It was a really large point. And at the bottom of the DFT, discrete Fourier transform, there's an envelope. So it overlays everything. And it was really big and really scaled to this one. I don't know why the point was there. It was just a really quirky thing. Anyway. I'm going to grab as much as I can. If only I could do this while I was talking better. And there's just little windows in here that I'm kind of a perfectionist. Okay, almost done. Come on. Come on, can't get it. There it goes. Whew. All right, so I think I have it all. There's a little bit of floor in here that I could get. And again, I'm anal about stuff like this. And I'm gonna leave that alone. So I have the inlet, the fan housing, the bearing cover or the shaft cover right here is a bit of a problem because it's sheet metal and it rattles. Same thing with this. This is a little stiffer made, but it moves. It guards the shivs. And the motor's moving around. There's a lot of flexure under here that I want to show you. Okay, so it looks like I'm good. I hit the accept button, and it's gonna go and grab all these points that I've highlighted. It calculates the average, and it subtracts it from everything I haven't selected. So now I get just the real motion in here, and I'll get the camera motion removed with all the red points. Now, when it comes up, it jumps in and starts animating in the time waveform. There are some applications for the time waveform for orbits and things like that. It really works well. It's just getting access. So in this case, guards had to be on. We couldn't even see the bearings. They were behind the guards. So a little difficult sometimes. But the background removal works really well here. Here's my 1790 peak, and it's bouncing around. It looks like I have a little bit of miss there. But anyway, you can see how this works. And let me add this a little bit. There we go. So I filled the whole page with it. There's a little bit of a gray border. Here's your X, Y, and Z. So Z is coming straight out from the object. X is horizontal and Y is vertical. Okay, so I can see there's a whole rigid body motion type thing going on with the whole fan structure at 1800 RPM. We have another peak in here, which is, let me go find, there it is. It's at 1670, which is the fan speed. And that gets a little funky. Take the amplitude down a little bit. And you can see this type of motion. Little story about this. This green frame under here goes on the all the way to the other side. Obviously, the fan sits on it, the motor sits on it. It sits on isolators. This is on the roof of a, I can't tell you what it is. It's a processing plant. It sits on isolators. So there's 4 isolators on this thing, which was probably not enough. They only replaced the front ones up here. The back ones they let go, and so they had, some were bottom out and some weren't. I don't know why, if they didn't have enough isolators or what. But about 2 weeks after we were there, one of the fan bearings seized and we broke a shaft. So there's plenty of motion. This should have spurred everybody into action to get new isolators put on. I can even see some misalignment in the belt drive just from the guard. It's the way the guard's twisting. So it had some problems and should have been addressed, but it never was. What else do we have? We have some other peaks out here, and we don't know what those are. And it is a belt drive, so we should be seeing belt harmonics. And I think this might be, no, that isn't it. Why does that keep popping up? There's something at 400, 438 or something like that. There it is. This is an envelope plot down here, so it overlays everything. I just like to see the other peaks once in a while. So this, if I increase the amplitude a little bit, kind of a bounce there. I think it's the belt frequency. Belt frequencies typically are in 2, so 2 times belt frequency, you get 2, 4, 6, 8, a whole string of them, and that might be what's littering my band down here, the noise floor. What am I doing here? So anyway, I'm going to remove background. I can do my record video. I click that and a video pane shows up. This is delete the sound. If you like to hear the sound, leave it on. And just count to maybe 8 or 9. And easy enough, it'll grab your data if you let it. Anything in the window. So if you want to just have this picture in there, you can do that too. You just have to manipulate, close these windows or move them shut, and it should work out. So I can hit the save button or the close button. I'm going to hit save, and I'm going to do something like that. Do you want to save? You want to replace it? Sure, why not? Okay, maybe it won't let me do that. So I'll close. So one of the key things is getting to this point. where the background's not moving. We can actually see the true motion of the machine, and then we can start picking peaks to look at and see what we want to do. And we kind of hone in on the problem. I'm going to do an ODS-FRF right now. So if I click on that, it's going to have me pick a reference on the machine. I think I usually go right here. So 0.2217 or 15 is a part of the bearing housing of the motor. So it defaults to, based on your frame rate, the block size. So it tells the software what the block size is. It shoots for getting 25 averages and 95% overlapping in a handing window. And when it does that, it really has a smoothing effect on the data. So let's do it. We hit accept. And we wait a few seconds. There we go. So again, it goes back to the time waveform, which still includes the background motion. If we go here, see how it's cleaned up the baseline a little bit. It's not hashy anymore. Here's my 1800 RPM. So it shows me the rigid body motion of the fan kind of rocking. And here it shows that twist in the motor. I've done some other processing from the back direction, and you can see this motor twisting and bouncing with whatever's going on in the fan. So I can get in there and do some more video, things like that. What are these other peaks? I'm not sure, but there is a way to find out. They're probably, some of them at least, are aliased peaks. So I'm looking at order filter. And what this is, it looks crazy, but it's showing me what's in this band and multiples of that. So that's what's at the bottom here. What I'm looking for is to go to 1800, because that's the speed of the motor, 1790, and see what's related to it. So I don't see anything right now. There's 1 times, there's twice turning speed, 3 times, 4 times turning speed. So I have a little bit of a peak. They put this on a zoomed in scale at the bottom. And I don't know if we see, oh, I can do expand orders. And you can see there's a little black dot now next to all the red dots. And that is where the aliased peak should be, if it's there. And it's barely there. What's left is things that you can go ahead and animate. You can animate the first 4 frequencies here. It's a 4-pole motor, except it cuts off for F max. The orders filter expands those orders out to twice whatever your turning speed is. So I get another 4 orders out here that I can animate. And they're all, you know, in this case, it would be considered looseness if they had a high enough response. I'm going to look at 1670, and this shows me turning speed of the fan, twice turning speed, 3 times turning speed, 4 times. And then if I expand orders, let's close it down. There's my 4 filtered blocks. If I expand orders, I get 8 now. So here's my first one, second, third, fourth, and here's the ones that were above F max that we've unfolded. And I can animate all those as well. Okay. Let me see what this is. I think this is the belt frequency, or it's either belt frequency or twice belt frequency. We have a whole series of harmonics here. Nothing really sticking out that's gonna spur anyone into action, but low level belt noise. Okay. Oops, shoot. I got to do that again. Hold on a second. I didn't save it. So orders filter. I'm going to go into 1670. That's my one of interest, so I can see some harmonics. I can expand my orders, see all the non-synchronous or the alias peaks in there, and then I'm going to hit accept. So it's going to keep that for me. Now, if I go back in here and I say switch result set, I have the original. I have the original with background removed. I have ODS-FRF processing of the frequency signal, and then I have an orders filter at 1670 RPM, and it's expanded. So I can go back and do all kinds of nice stuff with that. And it, you know, puts your program in, or your data set in a box where you can come back for it and don't have to reproduce it again. This one's the part that's a little shaky for me. I haven't played with it very much, but it's, excuse me. I think I wasn't talking. Hold on a second. Let me go back. Okay. I'm going to go in here and edit point graphics. And I mentioned before, we had it in the previous menu wizard, and we brought it forward into the post-processing wizard. I'm going to click on that, and it's going to open up the points spreadsheet. I want to go into it again, and I want to, let's edit orbits. I think I missed something. No? Got it. Okay. So I'm going to go in and hit this button. I'm going to, there we go. I'm going to do an interactive select. So it's individual points, and we're going to repeat. So if I put a dot there, these are hard to see too. They're red dots on a yellow. So I just put several dots going around this belt guard. I know it's a horrible place to measure, but I just wanted to show them a little bit better. So I hit accept, and those dots should stay put. Where are they? Where is it? Orbits. There they are. So here it is, all the different frequencies, and that's caused by all these peaks in the spectrum. I'm going to go into this and look at the orbits. So I made several spots on here. Zoom in a little bit. And I can reduce that. I can pause and continue it. I can put vectors in, all kinds of different things. So this was just several points that I put across the structure so I can see what direction it's really moving in. So you got a lot of vertical motion up here, kind of a crossover where you can see kind of where this node line would be. And then it starts to get a little more horizontal out in the end. And yeah, there's a lot of motion here. Probably not as much as we're leading on with. See if I can decrease it a little bit. Makes a little more sense. Now I can see the orbits a little bit better too. So the whole structure's moving. I mean, it's pretty amazing. You know, it's a bad foundation. I tell my wife over and over again that at least half of the problems that I see are foundation issues, and not necessarily, you know, bearings and things like that, but it all spawns to, if it's not bolted down correctly, you're going to get lots of response, and usually the outcome's not very good. But a lot of, you know, they have their bellows in the right place, so they're not stressing out the inlet. Nice different things that they've done with this thing, but it's sitting on a roof, and it doesn't have proper isolators and it failed. So let's see what else we have here.
Just want to jump in. If anybody has questions as we're getting towards the end of the webinar here, feel free to type your questions into the question box there, and we can start to answer some questions.
I think I hit everything actually so far. So
mag phase, did you show mag phase?
I didn't do mag phase. I'll try that.
Just
edit point graphics. I go into edit mag and phase. I make myself an interactive series of locations. So one at a time, interactive. I'm going to do one there and one here. Those are the bearings on the motor. Oops. Okay. And then I'm kind of hard up here. This is a difficult location for seeing anything since it's under the shaft guard. Yeah, let me do something right out here. See how this housing's moving. So like I mentioned, there's what just happened? I'm getting good at this now. Okay, so we'll hit accept. And go edit mag. Oh, no, that isn't what I wanted. Cancel. I wanted should have deflections, mag and phase. There they are. So it shows me what point I'm on, you know, what the magnitude and phase are. And it looks like here there's X and X are about 90 degrees out of phase, and my Y's are 180 degrees out of phase. And you can see how that motion would look there. Here they have, I didn't turn my orbits off, but I have some good information there. So let's see if I can find orbits. Yeah, so I got my orbits turned off. Okay, pretty easy. Nice. Once you know how to do it, but it's you know, first couple of times you got to try a little bit and fail. Like Mark said, that's about what's left in the toolbox. I was thinking about other stuff that I'd like these guys to program in, but I don't want them to hate me too much. So I put those off. Did you get any questions yet, Mark?
First question here from Marion. Suppose you have a very high background spot. Should remove measurement point rather than average, right? Basically.
It depends. If there's I don't know how to describe that. If let's say on my screen here, there was a really high spot on this deck that's kind of hanging out nowhere. It has nothing to do with this fan. You should definitely try to get rid of it. Actually, it might, if it's really big, it might mess up the average that we were talking about before. In that case, you'd probably use this one. Delete measurements of selected points. So we could find this. Let me give it a shot here. Interactive point select. I'm gonna do this, and I would come in here, do something like that. Do accept, and it should delete all those points. Except we're in the time domain, so we have to go back over to frequency. So when it came back on it, it went back to the frequency, not this went to hertz for some reason. Yeah, something defaulted back, so we'll have to look at that. Any other questions?
Just a comment, Marion mentioned, nice to show orbits and mag phase on the same points.
Yeah, it is.
For sure. If you have some additional questions, feel free to go ahead and type those in. Sorry, go ahead.
For me? No, I wasn't going to say that.
Okay.
Well, one thing, different directions. Right now we're looking at the side of the machine from a little bit of an oblique angle, but get another one going axially to the motor and you'll see a lot of different motion all in the same, same machine.
Yeah. We got a couple minutes here. If anybody has any additional questions, we can answer for you.
Nobody's going to ask me about aliasing?
You must have answered it.
Maybe. It's really hard to answer that without a picture, but that orders filter really helps.
Okay, here comes another question here. Is this algorithm by digital image correlation, DIC? He's asking what the algorithm is.
The algorithm is optical flow. It's been around for a long time. It's been in video processing for decades. I don't know much about it myself. I'm not a programmer, but it's ideal for this application. And what everybody struggles with is how long it takes to do anything. And the faster you can process, the better. So a lot of other attributes are coming out of this, different ways of doing the optical flow that's going to be beneficial for really complicated things, large points on structures and stuff.
Okay, no other questions at this point.
Good, I need a nap.
A nap?
Yeah.
It's Friday afternoon. I do want to remind everybody, we will get this up on our YouTube page, so have a look at our YouTube page, and all of our webinars are up on the YouTube page, so if you missed one in the past few months, you can go out there and get to view all of the past ODS videos, or excuse me, video ODS, I can't even say it yet. Video ODS webinars are all posted out on our YouTube page. There's, gosh, I think we're about up to 25, 30 of these right now. So there's quite a few of them out there going past, gosh, it's probably been a couple years now we've been doing this. So, and I encourage you, if there's something you'd like us to show, if you want to, we always get a lot of people interested in the case studies, so we'll continue to do that. But if there's something unique that you'd like us to do a webinar on, please go ahead and shoot us an email, sales@vivetech.com. Question here coming in from Bob. Can you discuss the difference in light algorithm of MEscope, RDI, and MSI, motion magnification? Answer only if comfortable.
Compare and contrast.
Discuss the difference in the algorithm.